Today we are learning about exponents. We're starting a new chapter. I know I've got this when I can evaluate exponential expressions, use the product rule and power rule for exponents, use the power rules for products and quotients, use the quotient rule for exponents and define a number raised to the 0 power, and decide which rules to use to simplify an expression. So key vocabulary is exponential expression, power, base, exponent, and common base. Exponents that are natural numbers or shorthand notation for repeating factors. So for example, 3 to the 4th means 3 times 3 times 3 times 3, where 3 is the base and 4 is the exponent, which is also called the power. Note by the order of operations that exponents are calculated before other operations. By the way, let's get this straight right now. You say 3 to the 4th, not 3 to the 4th power, that's assumed. Not 3, 4, it's 3 to the 4th. Okay, so number 1, I do, we do, you do. All right, so evaluate the following expressions. 3 to the 4th. So we would write that 3 times 3 times 3 times 3, which is 81. B, -5 squared is -5 times -5, which is a positive 25. Okay, so how is B and C different? I want you to really realize this. In B, the negative is inside the parentheses with the 5, saying that that negative is also being squared. In C, it's not. So C is -6 squared, but it's not in parentheses, so it's just negative. And then the only thing that's being squared is the actual 6. So 6 times 6, which makes that a -36. Okay, order of operations, we do inside grouping symbols first. So that would be 8 cubed, which is 8 times 8 times 8, so 512. Now you try to do E. And you should have gotten 3 times 4 times 4, which is 48. Number 2, evaluate each expression for the given value of x. So what we're going to do on this is just substitute. So we're going to go 3 times x is 5 squared. So we're going to be following the proper order of operations. So 5 squared is 25. 3 times 25 is 75. On B, we've got -2 parentheses x, which is -1 squared. So the correct order of operations with this is to do the exponents first. So -1 times -1 is +1. -2 times 1 is -2. So correct order of operations is very important for this lesson. And always, but especially this lesson. Okay, 2C is for you to do. So go ahead and pause the video and see if you can do these. Very good. Let me know if you have any questions. Okay, product rules for exponents. When you're multiplying, you add your exponents. So you have to have the same base in order to do that. So this is just an extra example I threw in there. Okay, so you would do 3 squared plus 4. So when you're multiplying, you add your exponents. So this will be 3 to the 6th, which is 3 times itself 6 times, and you get 729. Notice I did not say 3 times 3 is 9. I kept my base the same, and I just added my exponents. So when you are multiplying, with exponents, you have to have the same base in order to combine those. So this would be 4 plus 5, so x to the 9th. How many z's do I have all together? Remember, because I'm adding my exponents, so 3 plus 2 is 5, plus 5 is 10. Okay, with this one, I have 3y squared times -4y to the 4th. So I can multiply my coefficients, which is -12, and then how many y's do I have all together? 6. All right, the power rule for exponents is when you have a power of a power, you multiply your exponents, okay? So when you're multiplying, you add your exponents. When you have a power of a power, you multiply. So this would be 2 to the 9th because I have 3. So that would actually turn out to be like 3 times 3, which is 2 to the 9th. And if you do that, you get 512. This would be 4 times 2, so x to the 8th. So the power of a product rule, basically when you have a parentheses with multiple things inside and you have an exponent on the outside, you have to distribute that exponent to everything inside. So here we go. So simplify 5x squared y all cubed. So what you're actually going to do is you're going to cube everything inside here. Okay, so the 5 has an exponent of 1 right now. So you're actually doing this. I would honestly never write that out, but I wanted to show you what you're doing. So 2 times 3 is 6, 1 times 3 is 3, and then 5 cubed is 5 times 5 times 5, which is 125. Okay, power of a quotient rule. Again, when you have an exponent outside of a fraction or anything that has multiple terms inside, you distribute that exponent to everything inside the parentheses. So 3b, we have to simplify this. So I'm going to distribute that cube to everything inside. So I'm going to say 3 cubed x, 2 times 3 is 6, 1 times 3 is 3, 2 cubed is 8. I should have written that. Hold on. I didn't mean to skip a step. 2 cubed, and then y cubed. So 3 cubed is 3 times 3 times 3, so 27 x to the 6 z cubed over 2 cubed is 2 times 2 times 2, so 8 y cubed. And that is my final answer. Okay, here's one for you to do. So go ahead and try. Pause the video. And that should have been your answer. Okay, so quotient rules for exponents. So when we're multiplying, we add exponents. When we have a power of a power, we multiply. When we're dividing with exponents, we actually subtract the exponents. So 4a, it says simplify the following expression. Okay, this is how I like to do it. I feel like my students learn really easily like this. 9 divided by 3, I'm just going to simplify that. So 9 divided by 3 is 3. Now, to do the variables with the exponents, this is what I ask myself. Do I have more a's on top or bottom? The top, because I have a to the 4th, which means I have 4 a's on the top and only 1 in the bottom. So I have more a's in the top. How many more? 3. So I write 3. Do I have more b's in the numerator or denominator? In the numerator, how many more? 5. That is all you have to do. Okay, so 4b says simplify the following. The thing about this is everything to the 0 power equals 1. That is very important. It does not equal 0. Everything to the 0 power equals 1. So these all equal 1 because they're all raised to the 0 power. Now, I want you to see on D, you have a negative sign out in front, which means that is not included. X to the 0 power is 1, which is why this whole thing is -1. If it had been negative x to the 0, then that would equal a +1. But since the negative sign is not being included with that exponent, it's not. You leave it out. Okay, I want you to try these. Okay, I'm going to do some of these with you. I hope you've already done them. So 8 squared is 64. 3 times 2 is 6. 2 times 2 is 4. And 0 times 2 is 0. So c to the 0 is 1. So you just list this. Okay. On F, we have -3 cubed is -27. That would be 2 times 3 is 6. Y, it's 5 times 3 is 15. Over 2 cubed is 8. X cubed, z, 2 times 3 is 6. Now we have to see if we can simplify that at all. And we can. So I can't simplify the -27 and the 8, but now I look at my x's. Do I have more x's on the top or in the bottom? The top. How many more? 3. So I just write it like that, and I can't simplify the y's or z's at all. So that is my final answer. Okay, on G, -4 times -6 is +24. I'm multiplying, so I add my exponents. How many A's do I have? 5. How many B's do I have? 2. How many C's do I have? 10. So I write it like that. All right, in H, let's do the proper order of operations. So, goodness. All right, let me get my calculator for this one. 12 to the 4th is 20,736. A to the 4th, B to the 4th. Over 6 squared is 36. Then I have A to the 4th, B to the 4th. All right, so if I divide that and try to simplify, I get 576. My A's will cancel each other out, and my B's cancel each other out. So 576 is my final answer. So that is what you should have gotten. Okay, so I know I've got this when I can evaluate exponential expressions, use the product rule and power rule for exponents, use the power rule for products and quotients, use the quotient rule for exponents, and define a number raised to the 0 power, and decide which rules to simplify an expression. But do you really understand? Explain how to multiply two monomials such as 5x squared y and 5xy cubed. Then find the products of these two monomials. So you multiply the coefficients. When you multiply the variables, you would add their exponents. So the product is 30x cubed y to the 4th. Explain how you can use the product rule for exponents to show why 3x to the 4th squared is equal to 9x to the 8th. Squaring 3x to the 4th is the same as multiplying it by itself. So that's why you can do that.